Okay, so our question is asking how many of these molecules below are polar. And so to determine how these molecules are polar, we're going to use the net dipole movement of each of these molecules. So we're given SO3, OF2, BeCl2, CCl4, and O3. So the first thing you want to do is to draw out your Lewis structure and determine how many valence electrons it has. So here I have the Lewis structure, just the beginning of it, and I determine that it has 24 valence electrons because oxygen and sulfur both have 6 valence electrons, so in total you'll have 24 valence electrons. And then you will subtract 6 because you have 2 electrons for each bond, and that will make it have 18 non-bonding electrons. So that's when you're going to add it on the outside molecules, outside atoms to make octets. So each of these oxygens will get 6. And now we need to make an octet for our middle molecule. So this one will be a resonance structure because you can make a double bond here, a double bond here, and a double bond here. So for this resonance structure, we're just going to add a dotted line. So there'll be 1.33 bonds for each one. Next, we're going to determine the electronegativity of each atom. So oxygen has more electronegativity than sulfur, so it's going to have a partial negative charge. And our middle sulfur will have a partial positive charge. So that means our dipoles are going to go towards the outside oxygen atoms. Okay, from there, we're going to determine our electron domain. So our electron domain geometry, I'm just going to say EDG. So we have 3 domains, so it's going to be trigonal planar. And then our molecular geometry is also going to be trigonal planar. So let's draw out our molecular geometry. So we have our S in the middle, we have an O here, an oxygen here, and an oxygen here. I'm also going to draw out the dipoles. So since all the domains are the same, that means that there is no net dipole, which means it will be a non-polar molecule. Next we have OF2. So it has 20 valence electrons, fluorine has 7, so that makes 2 fluorine has 14 valence electrons plus the 6 valence electrons from oxygen, so we will have 20 valence electrons. And then we'll subtract 4, because we had 2 for this bond and 2 for this bond. We'll get 16 non-bonding electrons to add on the outside. So 6 will go here, 6 will go here, and 2 pairs of non-bonding electrons will go on the middle oxygen. So this fulfills all our octets. So now we have to determine our electron negativity for each molecule. Fluorine has a higher electron negativity than oxygen, so it will have a partial negative charge, and our oxygen will have a partial positive charge. So our dipoles are going outwards towards the fluorine. So our electron domain geometry, we have 2 domains, so that's going to be we have 4 domains. So it will not be linear. It will be tetrahedral because we have also these two pairs of non-bonding pairs. Tetrahedral. And our molecular will be bent. So we're going to draw out. We have our oxygen, our fluorine here. Then we have our two non-bonding here. And we have our dipoles going toward our fluorine. This one is different because the domains are not the same. Not the same. And our net dipole is going downwards. So that means that this molecule will be a polar molecule. So that answers part of our question here. OF2 will be a polar molecule. Moving on to BCl2. We have 16 valence electrons, 7 for each chlorine, and 2 for the beryllium. So 16 minus 4 from the bonds. That makes us have 12 non-bonding electrons. So we're going to add them on the outside here. We also have to remember that B is an octet violator. It wants to have 2 bonds, so it doesn't need to have a full octet. So that fulfills our chlorine though. So now we must find our partial and negative and positive charges. So chlorine has a higher electronegativity, so it will have the partial negative charge, and beryllium will have the partial positive charge, and our dipoles are going outwards towards the chlorine. So our electron domain geometry, there's 2 domains, so it will be linear. And our molecular geometry will also be linear because it does not have any extra non-bonding pairs on beryllium. So it's going to be B going out to 2 CLs. Our dipoles are going out towards this chlorine. And our domains are the same. And these 2 dipoles cancel out each other since they're going in opposite directions. So that means it is a non-polar molecule. All right, off to CCl4. So I have 32 valence electrons. We have 28 from all the chlorines and then 4 more from the carbon. So that makes it 32 valence electrons. We're going to subtract 8 because there's 2 for each bond. So that makes us have 24 non-bonding. And so we're going to add it on each of these chlorines to fulfill an octet. And our carbon has the 4 bonds it wants, so that also fulfills the octet rule. So we are good. Now to find the electronegativity. Chlorine has a higher electronegativity than carbon, so it will have a partial negative charge. And our carbon will have a partial positive charge. So our net poles, dipoles, are going outward towards the chlorine. So our electron domain geometry is tetrahedral because we have 4 domains on our center atom, and our molecular geometry will also be tetrahedral. So drawing it out, we have C in the middle, Cl, 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 and one more here at the top. Going down, our dipoles are going towards the Cls. And since all our domains are the same, there's no extra non-bonding pairs. That means this molecule is nonpolar. All right, lastly we have O3. This one's a bit different because now we have 3 of the same atom. So we have 18 valence electrons. Each oxygen atom has 6 valence electrons. We're going to subtract 4 from the 2 bonds that each hold 2 electrons. So we'll have 14 non-bonding. So we'll add on the outside atoms first to fulfill the octet. And then we'll have 2 more here in the center. Now our center atom needs a octet. It's missing 2 more electrons. So here where it's going to have a resonance structure. So we're going to have a dotted line here. And these 2 outside atoms, electrons will go away. So we'll have 1.5 bonds on each side in order to fulfill the octet on the center atom. Since it's the same atom, they both have the same electron negativity, so there'll be no net dipoles. So let's write out our electron domain geometry. Our electron domain geometry is trigonal planar because we have 3 domains. We have our oxygen here, here, and then we also have this one non-bonding pair that we have to remember. So you have trigonal planar, and our molecular geometry will be bent since we have that one non-bonding pair on the top. So let's draw out our molecular geometry. We have an O here, O in the center, and then we have our one pair of non-bonding. Again, there's no net dipoles since they're all 3 the same atoms. However, our domains are not the same because we have that one non-bonding pair at the top, which makes this a polar molecule. So that makes us have OF2 and O3 are polar molecules in this situation. Some common mistakes is that we incorrectly draw our Lewis structures. We forget to think about using all our valence electrons and finding all the octets. But we also have to keep in mind that some have octet violators, like here in BCl too. And also we have resonance structures, so we have to keep in mind with that, like our SO3 and our O3. And then we also need to remember to draw our molecular geometry because that will help us find the net dipole movement and help us find whether or not it's a nonpolar or polar molecule.